Hey, Wade, can you hear me? I can see that you're there. Oh, you're muted. You can type me a message if you want to. If you're shy. Um, yes, I'm talking. Can you not hear me? Turn up your volume. Can you hear me now? Yay! Okay, here we go. Um, which was there a particular worksheet you were struggling with, or you just want me to start over? Oh, cool. Yeah, no, I can't hear you, but I can see what you're typing. But if I leave the page and come back, like sometimes I leave the page so that I can bring up another page so that you can see what we're talking about. So I can't, so I wouldn't, unless you're talking, I wouldn't be able to hear you. I can only see what you're typing. So are you talking? Let me see. Let me turn my volume up. Maybe my volume's down. No, my volume's all the way up. So are you talking now? Boo. I can't hear. Um, Wait a minute. It says that, oh, did you just push mute and then unmute to see if that was going to work? Because I saw the little microphone on here that came up and went away. Go to settings and press speakers. Where's settings? Okay, now talk. I still can't hear you. I'm playing the test sound. Go to the settings and press speakers up at the top. I did. Okay, well, mine's not working. Mine was all set to default, and it seemed to be okay. Can you still hear me? Huh. I can't hear you at all. That's a bummer. Do you have a headset in? Oh. Because I know one student I had a headset in, and that's kept them from being able to hear. Anyway, was it mostly Monday stuff that you struggled with? I'll try to get all of your questions on the text box, and then we can come back. Did the videos today help with the parent graph stuff? Okay. Here's what I think I'm going to do. Oh, okay. You don't understand how to do it without using Desmos. Okay. All right. That's cool. I kind of get that a little bit. But it made more sense when the video showed me how to figure out the points. Yeah. And then the worst part about it is, let's see, I'm trying to think. Because I had like 4 videos picked out for today, and I know I narrowed it to 2. But the guy ended up not graphing the second half of the graph right, if I'm not mistaken, which was kind of a bummer. I mean, I'm going to show you, hang on, and now I won't be able to see what you're saying because I'm going to use, but Desmos is okay to use to get an understanding. That's not a big deal. But this, bye Caleb, be careful. Love you. This right here is obviously linear, and so you're going to go, this part right here is where you're going to go either left or right on the graph, and it's the opposite. So like when I say it's opposite of what you would think it would be, obviously for you and I, when we think minus, we think left because you're going to go left to the 0, but basically what it actually means to go right, because when you pull a number out, like let's just say, hold on, let me put a real number there. Let's just say we put 4 there plus k, or plus 4. We'll just make it real easy. And this is a linear graph. So what that means is instead of it just being a regular, starting at the origin like a regular line, it means it's going to go, this is actually, since the original equation is a minus, you're pulling a positive out, and this is a plus. But since the original equation is that, if you had y equals x minus a minus 4, that's what makes it positive. So it's the actual opposite. So for this particular one, it's a positive 4. I'm going to go right 4, 1, 2, 3, 4, and up 4, 1, 2, 3, 4. And instead of the line starting at the origin, hang on, sorry about that. Instead of the line starting at the origin, like most lines do, it's going to go that way. It's going to start up at the top. So it's going to be shifted. Does that make sense? And obviously this was just, okay, yeah, that makes sense. If it's in the parentheses, it's opposite. Okay, cool. I'm just coming back. I'm coming back to check out any questions that you have. And now I'm going to switch back, so I won't be able to see what your questions are, and then I'll come back. So, and this is just all linear. This particular problem, but I think it helps to start with a linear equation because that's the most simple, and then we can kind of go from there. Now, when you switch to a quadratic, which is probably the next one that we learn, it's going to be x minus h, and then this is squared plus k. So, and I meant to mention this to you. This thingy right here, that for the linear is the slope. So let me just write an equation. So let's say its slope is 4, and then x, and then the minus 3 plus 2. That means you would go right 3 up 2 instead of it being, at the origin. And then the slope, the steepness of the line would be 4. That's for a line. And this is a quadratic. So what happens with a quadratic, remember a quadratic, that parent graph literally looks like this and goes through the origin. So the parent graph, which is this, it just literally looks like x squared because you haven't moved the x and you haven't moved the k, nor did you adjust this part, adjusts and makes it how skinny or fat it is. So a better way of thinking it is if this was a whole number like 2, it's going to squish in toward the y-axis because it's kind of going to get steeper faster, just like how slope would adjust it. And we'll do some Desmos and play with that in just a minute after I get done going over this with you. So this is the parent graph. Now, if we adjust this ever so slightly and say, okay, x, we're not even going to do anything with the a yet. Ever so slightly, we're going to adjust it. We're going to move it right to, and then go up to on the y-axis. So it's going to move it from here to, it's going to go right 2 over 2. So it's going to do that, and it probably wouldn't intersect anywhere until way up there. But it's kind of going right 2 and then up 2. So these things right here adjust this point right here. And this right here, if we added an a, that's going to make it whether it's skinnier or fatter. And so let's go to Desmos and do a couple. Can you still, let me go back and see if you have any questions first before I switch. Okay, are you good? Okay, cool. Did this help? Oh, I love the smiley. And he's blinking at me on top of it. That's what I like about this. Okay. All right, well, so now let's go back and let me do Desmos. And let's just type in the 2 that I just talked about. X. Oh, Lord Jesus, help me find it. There it is. All right, and now what did I type? Y equals x minus 2 squared plus 2. So we didn't make any adjustments to how skinny or fat it's going to be. So now we're going to work with that a part at the beginning, and let's just keep it kind of simple and keep our 2's going. And then x minus 2 squared plus 2. So it made it the green, so it got skinnier. And now what I'd like to do is do y equals, and then 1/2 x minus 2, keeping it relatively consistent, not changing too much about each of them. And that 1/2 actually makes it fatter. So, and how Miss Stone, which I kind of like, I like how she says on the little assessment that you're going to have tomorrow, basically for our purposes of knowing how well you all understand this. But she actually asks it in this way, because what we were all noticing in class is like it seems to your idea of either stretching or shrinking is slightly different for each type of graph. Like when we go to the square root, it changes a little bit. So a better way of thinking about it, do you notice on the orange line with the 1/2, I basically said that it got fatter, which indeed it does. But another way of thinking about it, it's kind of moving away from the y-axis as being the center and kind of spreading its wings so that if you were probably 1 over, 1,000 or something like that, it would be getting closer to the x-axis. So she said, I don't know if you can hear my dog snoring, Wade, or not, but my dog is snoring so loud at this moment, it's hard for me to focus. That's crazy. It's Finn, too. Anyway, can you hear him? Oh, of course he quit as soon as I asked. That's so funny. Finn, you tired, buddy? Anyway, back to this. On the 2, which is the green line, it gets skinnier and kind of squishes toward the y-axis. So that the A part of that formula, which I'm going to switch back to the formula for just a second. The A part, now I'm throwing my pointer around. The A part of the formula really, if you want to, obviously it's not slope when it's a parabola, but it's kind of like slope in the fact that it changes the overall appearance of either the parabola or even like with your cubics or your square root. It changes the appearance in that it's either going to move it closer to the y-axis or closer to the x-axis. That's what that A does. That this part moves it in and out from the x and y. And then this part right here, the H, that's going to move it left or right. And if it's a positive, it's going to move it left. Positive moves it left. And it negative moves it right, because when you pull it out, you're really just focused on that, whereas the original equation has a minus in it. Well, on this one, this part right here, this is the y, and that's going to tell you whether it goes up and down. And in the original generic formula or equation, it is a positive. So that's just going to move along your y-axis, and this moves along, oops, my bad. This moves along your x, and this moves along your y. It's really messy, but I don't know. Does that make a little more sense? Would you like me to show you on some of the others besides the quadratic, or do you feel better about it? Okay, good. So the A makes the graph skinnier or moves it toward the y as far as the overall, the whole graph as a whole. And the A sometimes can be a little, elusive, if you will. But I am going to let y'all use Desmos tomorrow because I think Desmos has a really good clarifying effect for parent graphs. So the H only moves it left and right. Yes, sir. And the good thing to know about the H is it has to be enclosed within, like, okay, so if it's an absolute value, let me write that over here. Let me do that. Ugh. All right, let me write that. I'm on Math Lab, Brookie, just so you know. It's Wade. Say hey to Wade.
Hey, Wade.
So if it's absolute value, it would be inside the absolute value. So if, let's say it looks like this, the absolute value of 2 plus 4. Oops, absolute value of 2.
He says, hey,
My bad.
Too.
Oh, I know, he's been snoring. Oops, yes, sorry. I need to fix that. Okay, this one, this doesn't move the H at all. So this one is going to look like this. It's just going to go up 4. 1, 2, 3, 4. So the absolute value graph looks like this, and it's not going to move the H at all. If you had this, since it's inside this part right here, that's where the H is affected. So it's going to move right 2 and up 4. So this one looks like that. So it actually has to be inside either, okay, so like on the cubic, for it to move, it would have to be inside this cubic thing for it to move. Inside the either the parentheses, the absolute value, or the square root. Because I think, what have we learned? We've learned linear, we've learned absolute value, we've learned square root, we've learned quadratic, and we've learned cubic. I think those were the only ones that we learned, right? So far? Okay. So the H moves it left and right, and it has to be inside the parentheses of some sort, or the absolute value, or the square root. And the K moves it up and down, and the A squishes it either in or out. And that's the differences. But you will be able to use Desmos tomorrow, or your graphing calculator, either one. Some people actually like using the graphing calculator more because that's what all those lines are for in the graphing calculator. You know, when you hit the y equals, and there's like a whole bunch of y's that show up, and they that's what that's for. Oh, you don't know how to use it? Oh, okay. All right. Well, I'll definitely show you that because that will be really, really helpful for you on the SAT and the ACT. So I need to make sure you know how to do it. So please bring it tomorrow to class, and I can show you how to use that and Desmos. But you can use Desmos for the Miss Stone didn't really want her students to do that. But I really do want you guys to be able to see it and be able to type it in. But some of them you should be able to just look at and tell, oh, okay, this is going to move left or right. And that, you won't even have to do the graph. Well, actually, yeah, you do have to do the graph. But I really just want to mostly know that you're like, if you have, let's say, you have a problem like this. Let me switch back. If you have, well, goodness. Um,
Do you have this recipe on your phone?
no, baby.
What'd you put in it?
Oh, I'll have to show you.
Alright.
So let's say on the assessment tomorrow, I have x minus 2 under the square root plus 4. I would want you to tell me that the graph is shifted right. I'm just going to abbreviate right. 2 and up 4. Does that make sense? Okay. All right. I'm going to give you one, and then you tell me how it shifts. Just to be on the safe side. And does it make sense that the generic formula that I gave you earlier, the A, open parentheses, X minus H, close parentheses, plus K, does the A, the H, and the K, all those things, does that make sense? Like it's going to absolutely change it for every single graph. It's not any different for any graph, whether it's a cubic. Okay, cool. All right. Let me go back, and I'm going to put one up there, and you tell me how it shifts. And I'm not going to add the squishing, but we can talk about that some more if you need to. So if on the quiz, if I have something like this, what would you tell me? Yes, that's perfect. You've got it. That's awesome. You didn't need me after all. Do you want me to ask you a few more just to be sure, or are you good? Do you want me to put some squishing on there? The A part? Okay.
I want my chewing paper.
I got you. That's sweet. So my shifts would be what? And then is this going to make it skinnier, like moving in toward the Y, or is it going to make it fatter? Okay, so left 1, down 4, and it's going to make it skinnier. Good job. So it squishes in toward the y-axis. Good job. And the cubic. The only thing it really changes, as far as shifts are concerned, it's going to go, you know, your left and your up and down don't change at all. The other part, let's go just do some cubic so you can see, because it's that one that actually goes from quadrant 3, and so the shifts do make it look a little weirder, but it doesn't change as far as up and down are concerned. The squishing looks different. Ugh. The only way that it really changes it, to me, the skinnier and the fatter piece are a little harder. Whoops, might be. Little harder to kind of distinguish on that. So let's take a look at it. You can kind of see the red as the parent graph. And then my blue was my second one where it shifted right to and up. So it changed the where it was. Instead of going through the origin, it's going right here. I don't think I can write on this. At the 2, 2. All of them are kind of because I have the 2, 2 there. But this 1/2 piece right there for the orange, I don't know if you can see the distinguishing difference, but see the green is a little bit skinnier. And the orange is a little, oops, my bad. It's a little bit fatter. So it stretches it out more. Like, all right, just to kind of give you, but other than it doesn't really change what you're going to say on a quiz to me. As far as it's shrinking and stretching, because the green is just getting a little skinnier. X minus 3. I think it helps since we made the, see how much, with the 1/10, you can kind of see how much fatter it got. Like, these are skinny curves and this is a little bit of a fatter curve. So I think it kind of helps to make it a bigger number. Does that? Yes, that's it. You absolutely, you nailed it. That's it, exactly. So the steepness, much like the slope, of a line, if you think about a line, when the slope is like 2 or 3, it just keeps getting steeper and steeper. And yet when it's a fraction, it is lower to the ground, closer to like a straight line, if you will, like a horizontal line, because it's obviously getting closer to 0, and the slope of a horizontal line is 0. So that's, I don't know if that's easier for you to think about it maybe that way, moving closer to the x-axis because x is horizontal, and then the larger the number goes, it's moving toward the y, much like, if a regular straight line had a steeper quote-unquote slope, it would be moving toward the y-axis. But I think it's good to understand these different parent graphs, because as we introduce hyperbolas and parabolas and stuff like that, you all will be able to see within the equation how moving it around the graph, how to manipulate it, moving it around the graph, how it translates from an equation on a piece of paper to an actual graph. Is there any other questions that you have? Oh, good. I'm so glad. And I'm trying to make Math Lab at better times for people. Are these later hours better for you? Like the 4s and the 5s, typically? Oh, okay. Well, this really is, I wanted to help you before I made it public, but this is exactly what Math Lab is. This Okay, that's cool. I can do that. Plus, I feel like I know a lot of the chemistry students don't finish until 1:30. So, okay, cool. But this is exactly what it is. And so that, you know how I emailed you the link and I said just click on the link? Was it pretty easy just to click on that? Did it come right up then? Okay. Well, that's the link that I put in the lesson plan and that I put on Google Classroom. So all you would have to do is if you were in Google Classroom, you could just click on that link and it should take you there, or if you're on the lesson, it should take you right in there. But I was going to make it public, but I just wanted to make sure that you understood everything first and I answered all of your questions. But most of the time, only one or two people only show up anyway. So but that's what I'm going to do. I'm just going to go ahead and make this public and put it on the lesson plan now and in our Google Classroom and see if anybody else has any questions. And I'll just kind of leave some of this Desmo stuff up so people can come and look at it. But this is literally how Math Lab works. Hopefully we can figure out how we can get your mic working. It does help me. I do have students who don't ever talk and they always write all of their questions in the chat box, or they email me their questions first and then I go on and I know exactly what they want. So like, if you were struggling with something on a worksheet or whatever, they'll just say number 2 in the textbook on our homework or whatever. And then I'll go over those questions specifically in Math Lab. But this is exactly what Math Lab is like every day. You can hear my children, you can hear my dog snoring, and maybe get some math help too. So yeah. All right, well, I'm going to try to move Algebra 2 Math Lab to the afternoon. And I've got Algebra 1 Math Lab in the morning, but I'm going to see if I can move it to the afternoon too, because I've got some kids who actually take Latin at the school and can't ever make it. But if you don't need me anymore, I'm going to make it public, or you can just stay on and see if anybody else has questions. I don't care. Whatever you want to do. And this is how I add a Math Lab.
It was good. Just as good as it was yesterday.
Oh, good. So that's it. Oh, no problem. I'm glad it helped. I'm very glad it helped. So you should be good tomorrow. But come anytime. Every Tuesday and Thursday I'm available. And you can email me beforehand also, and I can have the problem up and ready to go if you want to. All right. You have a blessed evening, unless you're going to stay with me.